Okay, so in our last section of Chapter 5, we're doing some problem solving, which means everything in this section we have done before, we're now just transferring that knowledge in order to figure out problems. Most of this is going to be comparing. So when we look at problem number 1, it's asking us which of the 3 sea animals is the fastest and how do we know? And so we have a bottlenose dolphin, a sea lion, and an orca. And so for each of these, in order to know, I'm needing to find speed, which is a slope. So here we are, we're going to compare slopes or unit rates, because that's really what these are, unit rates. So we're going to find our rate for our dolphin first. And I know that my dolphin goes 8.5 miles every half hour. So I can do that one of 2 ways. I can take, knowing that at 0 minutes we haven't traveled anywhere, that I can do 8.5 divided by 0.5 for the half hour. And also know that if I'm trying to find for hours, I'm just going to take 8.5 times 2. Both of them will give me the fact that the dolphin travels 17 miles per hour. And so then we move on to our sea lion. And I need to find its slope. And so I'm given a table here. Now the issue with this compared to the others is our time is given to us in minutes. So in 12 minutes, the sea lion travels a distance of 5 miles, which is pretty impressive. But at the same time, that doesn't help us with distance or miles per hour. So we have to change our minutes into hours. So either I change the 12 minutes into hours, or I notice that there is 60 minutes down here at the bottom of my table. And in 60 minutes, oh, that was a very terrible circle there. In 60 minutes, he travels 25 miles, which means the sea lion travels 25 miles per hour. Now, if that wasn't there, then I would have to change my minutes to hours by dividing by 60 and doing the math. But our sea lion travels 25 miles per hour, again, just by reading the table. Now for my orca, I need to find a point on my graph. I know that this is a proportional relationship because we are starting at 0, 0, and we've got a straight line. So now I'm just going to find, here's a perfect point, and it's just going to bring up my menu when I click on it. So here's a perfect point at 2,69. And so in order to find the unit rate, we're going to take, and this comes directly from, what was it, 5.2 when we were working with proportional relationships. So we're going to take 69 and divide by 2, which will give us 34.5 miles per hour, I believe. Of course, I didn't have my calculator handy. Yes, 34.5. So now the question is, after I have found all of these unit rates, now I compare them. And so which of these 3 sea animals is the fastest? Well, it's going to be the orca. And that's because it travels 34.5 miles per hour. It has the fastest unit rate. The fastest unit rate. So here again, we found a whole bunch of slopes, and we knew that they were proportional relationships, so we could do the division. As simple as that. One more problem for us. We have problem number 2. An 8th grade class wants to hire a DJ for their end of the year party. So we have DJ A, DJ B, and DJ C. We're going to write an equation that represents the total cost, Y, of hiring each DJ for X hours. So I'm going to go through each of these and I'm going to write their equation. So for DJ A, we know that it's $20 per hour plus a $75 setup fee. So If we go back to what we know from chapter 2, when we were writing equations, the only difference is we're not given how much we spent in order to find hours. We don't know, so that's our y. I don't know how much I've spent, but I do know that it is $20 per hour, which will mean I'm going to multiply, so 20x plus $75. So even if he's just there to set up and then ends up going away, you're still going to pay him $75. For DJB, here we have the point 0, right? So that means at 0 hours it costs nothing. So even in that first, if we only hire him for 1 hour or even 30 minutes, we'll probably have to pay $20, but we're not going to have to pay a setup fee, because when he first gets there, he's not charging us for a setup fee. So this is just going to be the fact that y equals, and for 1 hour it's $40, and if we notice 40, 80, 120, 160, so we go up in $40 increments. So y equals 40x. And then over here, we need to figure it out for DJC. And so when I'm looking at DJC, there are two things I need to find from this graph, because it's not starting at 0, 0, so it's not going to be a y equals mx. It doesn't give me the words for this, so I need to find my slope and I need to find my y-intercept. And I know that my y-intercept is here at 0, 50, and so I know my y-intercept is 50. Now I have to be careful on this slope, so I'm going to pick this other point, 175, and I know that it is tempting to just count up and over, and unless you keep in mind what your units are, I'm going to highly suggest you don't do that. And here's the reason. If I count up and over, and I just count it as boxes, you're going to give me that my slope is up 1 over 1. But if I go with the fact that here I have 0, 50, and here I have 175, and I do the subtraction, so y minus y, oops, I forgot to close that one, 75 minus 50 over 1 minus 0. Then I end up with 75 minus 50 is 25, 1 minus 0 is 1, so our slope is 25. Now again, that is much different than up 1 over 1. Now, if you recognize that this up is actually 25, and then we're over 1, that's fine, but you have to keep in mind those intervals before you just start counting boxes. And so then from here to write my equation, y will equal 25x plus 50. And so then there's my 3 equations. Now, which DJ charges the highest hourly rate? Well, that's going to be DJB. And the reason is because the DJA is $20, DJC is $25 an hour, DJB costs $40. Is making up for the fact he didn't charge you a setup fee. Which equation shows a proportional relationship between the number of hours and the total cost? Well, remember that the number, or to be proportional, we have to start at 0, 0. And so the only one that starts at 0, 0 is DJB at y equals 40x. That is our only proportional relationship in here, because the DJA starts at 75 and DJC starts at 25. So both of those are using our slope-intercept form and not just our proportional relationship. Now, if you only have $150 to spend, which DJ can you hire for the longest period of time? Well, my money is my y, so I'm going to take that 150 and I'm going to plug it in and I'm going to solve. So I'm going to subtract 75 from both sides here. And so then I have 75 equals 20x, and I'm going to divide by 20 so that I get that x equals 3.75. So right now that's what I have for DJA. I'm going to do the same thing here. 150 equals 40x. Divide by 40. And so x gives us 375. So right now they're at the same. And so now I'm once again 150 equals 25x plus 50, and so I'm now going to solve. Now this step here where we're plugging into y and solving for x, that is something you're going to be doing in your homework. And yes, I want work turned in for your homework. So 100, when we subtract 50 from both sides, divided by 25x, or divided by 25, gives us that x equals 4. So DJC is who we can hire for the longest time. And keep in mind, we're not going to say, okay, well, we're going to hire you for 3 hours and 70, or and 3/4 of an hour. We're most likely just going to hire on the hour. So DJA and DJB we can get for 3 hours, and then DJC we can get for 4. And so that's how we do 5.7.